Why are you smiling?
Who has a cooler job?
Ah, such an obvious answer. But I should start. So I think, obviously, in a data-driven manner, I can conclude that a data science job is cooler, data scientist job is cooler because...
My name is Nikunj Bajaj. I am a machine learning engineer at Facebook.
I'm Shrita Goripati. I'm a data scientist at Uber. I think we know each other through like friends. We were really good friends. I think Nikunj was like my first friend in Berkeley when we started doing our graduate studies together. We started in 2013. We were in different programs, but we had a common friend, and then we started like hanging out a lot and kind of just talking and going on walks, philosophical discussions, feminism, you know, Berkeley stuff basically. And then, yeah, I think it just kind of evolved into...
Eventually, we are married.
Yeah, we're actually, yeah, we are married right now, yes. So let's do rock, paper, scissors to who goes first. Rock, paper, scissors. I go first.
Go for it.
So, Nikunj, what do you think about the future of AI? Big question.
That's a big one.
Big question to begin with. Let's see what you say.
Okay. So I'm a machine learning engineer, and I'm very positive about the future of AI. Because I think that we haven't even scratched the surface so far in how we can leverage AI to improve our lives. Like, you know, it is already affecting our lives, the way we commute, the way we shop, the way we eat food. And I believe that it's going to go a lot more. And I have a strong feeling that in the future, AI will become such a nice counterpart to human beings that these two smart minds can just interoperate with each other and make the world a better place to live in.
Yeah, I totally agree with you. And I also actually am quite excited because I feel like we're in this situation where it's just scratching the surface.
Yeah.
And it's creating these opportunities, and I feel like we're all starting up in this journey of AI, and we can be the leaders who can actually make the important decisions about like privacy, safety, making sure that AI for good, you know, it's happening in that direction.
Right.
So I'm actually excited about not just the future, but like the roles that we can play in kind of me taking it forward.
Absolutely.
I'm ready.
All right, the big one.
Okay.
How did you become a data scientist?
Oh, yeah. This is I like this question. So I finished my undergraduate in IIT Bombay in civil engineering, and I was focusing on transportation engineering. So that's where I like really loved the field because it was extremely diverse. Like you could be doing anything. You could be focusing on kind of the behavior of people in transportation choices, how aircrafts fly, how do we manage airports, how do we model traffic on the road. So it was a super diverse field where you could really focus on any one part. So I was like, I need to spend more time studying, you know, and understanding this this area. So I did a master's in Berkeley. I kind of got a funded master's, so it was like pretty easy for me to come here and study. And so it was a no-brainer. I had to do it. And then during my master's, I actually, by pure like accident, I got introduced to this like course on which is an introduction to machine learning, and I was like, yeah, the name sounds fancy. Let's just go see what this is like. And I went, and I was just like, I was just so absorbed. You know, I would go and I was like, oh my god, like this, you could actually measure this. You could predict so well. You can actually understand how like where the rain will fall so accurately. Something I'm doing in my class, you know, is predicting the rainfall in Sierra Nevadas. So like we had these super cool course projects, and then I was like absolutely sure that I have to, you know, study more, apply my education to like some of the applied problems in transportation. And so I did my PhD where I was focusing on air traffic management and using machine learning to improve that and to provide kind of better tools and stuff. So, and then I did an internship in Apple Maps to understand like what do I want to do, industry or academia.
Right.
And then I just loved the fact that in industry the ideation to impact cycle is really short.
That's true.
Like you think of something, you prototype it, and then you experiment it, and then it's live in like a couple weeks sometimes, or even faster. So I just really loved that, and I wanted to pursue data science. I graduated, looked for jobs, got into Uber, and here I am.
Perfect match.
Yeah.
Transportation and data science, well, Uber.
And Uber, yeah.
Yeah.
Kind of worked out.
Cool.
So I think here this time we'll answer a little bit more technical questions on data science and machine learning. Let me start with asking you the question. So what's the difference between a data scientist and an ML engineer?
I think the term data scientist and ML engineer is used pretty loosely across the industry, I think. And different companies have different roles, different requirements from a data scientist and an ML engineer, and sometimes people switch hats as well.
Yeah.
So it's difficult to give an answer that's like conducive to all kinds of scenarios.
That's
However, in general, like when we think about an ML engineer versus when we think about a data scientist, there is still some difference that we almost fundamentally have in our head. So we could potentially talk about that. So when I think about an ML engineer, right, there are essentially two main parts to my role. One, that I'm doing machine learning, and I'm trying to build models to solve a particular product use case. And second, I'm doing engineering, as the name goes, right? So not only I'm building the model, but one of my main objectives is to take that model and deliver it to the end users.
Yeah.
That how can I build an engineering system which is robust enough, solid enough, that it can deliver that model to the users and then take care of aspects like what's going to be the runtime complexity of this thing, which part of this model would run offline versus which part of this model would run online, and think about all those elements of solving the problem.
Yeah.
However, in fact, I would like to hear like what is the data scientist job from you instead of trying to answer myself.
Yeah, that's actually a good point. Like it is very fudgy, I think, across industries, and there's a lot of locality. I think also not just like across different industries, but also the size of the company matters.
Right.
If you're in a very big established company like Facebook, like Uber, you have more well-specified roles. So it's like more clear what the differences are. Mm-hmm. But if you're working in a startup or a slightly smaller company, I feel like the roles really start merging and blending a lot more, because you need to be a little bit more full stack. So like in terms of like more big company situations where it's more clear what the differences are, as a data scientist, my focus is how do I solve problems that I'm seeing for my users at the end of the day. So an example is, I kind of alluded to the traffic before. So just continuing on that theme, if I need to find what's the time taken for Uber to go from point A to point B, like what's the travel time to do that, that's a real world problem. So as a data scientist, I come in there and I'm like, hey, how do I formulate this problem into a mathematical question?
Right.
So that's where I start to think about like what's the mathematical problem. So it's like, okay, so there is an origin, there's a destination, and I need to find the time to go from point A to point B. And so then I start thinking about, okay, so what's the data needed for that?
Right.
So map data, there's traffic information, there's some amount of like information on kind of the surroundings. Is it cloudy? Is it like there's congestion? Is it rush hour, etc. So I need to first collect data. So there's a lot of work on data wrangling, data cleaning, data querying, SQL, and all that stuff. And then once that's done, the next question is like, okay, now that I have the inputs, I need to solve the problem. So that's where, what's the right model for this question? What are the assumptions that are made for this model? Are they valid for this particular scenario? Do they make sense? So then I start to think about model training, model evaluation. And then once I have something that works, the next question is, hey, how do I know this is better than what I'm doing right now? Like it's okay. It's one thing to build cool models for the coolness, but it has to serve the purpose that of the problem, which is how do I predict the travel time to go from point A to point B, and it's better than the options I have right now. So that's where evaluation and metrics become really important. So I need to make sure that I understand what are good metrics for this problem.
Right.
Like what are the numbers that impact my users the most? Like what are the ETAs that are most important for the drivers and riders and the consumers of the app?
Right.
And then once I have these metrics in place and I can say, well, this is a good algorithm, the next step is, how do I launch this? How do I close the loop and like measure the impact on my users when it's live? So kind of going through the whole cycle of like going from a very abstract problem to like actually quantifying the impact of it end to end.
Right.
I think that's the data scientist. And the difference from what I'm hearing from you, which you really put well, is that I am thinking more of the problem solving and how to solve it, what to solve, and how to measure. And you're thinking of how do I implement it and how do I make sure, how do I deliver it. So that's kind of the theme.
Yeah. Do you need a CS degree to do your job?
Well, the short answer is no, because I'm employed in data science and I don't have a CS degree. So I think I'm living proof for that answer. But I think on a more serious note, so a CS degree is useful at the resume level. So I think at the resume level is when you have to kind of concisely put the information together that, hey, I have good skills that are relevant for data science, for machine learning engineering, and kind of the general area of this work. And so there, a degree comes in handy, because it's standardized. Everyone takes certain courses to finish a degree. So the person who's reading a resume says, hey, I know you've finished all these requirements. But that's not the only way to kind of put the information there. So if you can, if you've done boot camps, if you've taken any online courses, if you've done research projects, if you've done Kaggle competitions, that could be other ways to show your enterprise in data science and how you're kind of a self-learner. So once you go beyond the resume screen stage, I think what matters the most is what you know, not the degree you have.
Totally.
Because I've seen both cases where people have these just amazing degrees, this beautiful resumes, but they come on site or they come on a phone call and I'm just disappointed. There's really no understanding of how to solve the problem.
Yeah.
And I've seen the other cases where people have a pretty thin or scrappy resume, which without a lot of standard degrees, but they just know how to solve the problem.
Yep. And that's what really matters. We've taken a bunch of interviews and we understand that.
That's what matters to get the job.
Yeah.
Versus getting screened for the job.
Makes sense. Yeah.
So the question is, can a data scientist become an ML engineer and vice versa?
I think so. I think people make transitions from being a data scientist to being an ML engineer and vice versa pretty often, honestly. And the reason I believe that transition is not like a big jump is because anyways in your day-to-day job, a data scientist and an ML engineer have to work very hand in hand to deliver a solution. Because let's say a data scientist is building a model to solve a problem. One of the examples you mentioned is the ETA problem.
Yeah.
Now that ETA problem can potentially be solved using 20 different models. However, looking at the engineering, say within Uber, potentially not all of the models are feasible, either based on the limitation of some kind of data or based on the engineering system that is powering the app, right? So the data scientist has to understand some of the engineering aspect to actually make the right model choice. And for that, they have to understand, they have to have the ML engineering know-how in their toolkit, right? Similarly, an ML engineer cannot really design a system until they understand what goes inside the model.
Yeah.
Because some models can be training time heavy, some models could be prediction time heavy. Yeah. So they need to make decisions on what goes offline, what goes online, how do I make my database choices, how do I even implement the right algorithm, right? So for all of that, ML engineer needs to be pretty well versed with the data science models, etc. So clearly, although these two people understand each other's jobs, and that would definitely help when they're making the transition, I guess when they're really making the transition, they need to go knee deep into each other's role. Yeah. So for example, if you're a data science engineer and a data scientist and you understand engineering, you need to be able to go knee deep. So now you can start actually taking calls on you can make engineering decisions.
Yeah.
So you need to do some study or some practice for that, and vice versa. As an ML engineer, I understand some of the models, but can I actually make decisions myself?
Yeah.
Maybe I need some coaching for that. You need to understand a little bit deeper into the other role, but you can make the transition.
Yeah, that's a totally fair point. I actually have a couple friends who've made this transition recently.
Yeah.
They came from a startup as a data scientist, and as we said before, the roles can be quite different, in startups versus big industries. And they came in and they realized that what makes them happy is the more machine learning engineer part of the role than the data science part of the role. And they came in and they started like doing data science activities that I was talking about before. And they kind of like built more and more technical strength, more and more coding skills, and they made the transition.
Yeah, and I'm sure it helped that because they were coming from a startup, they probably were doing a bunch of different things, so they inclined more towards engineering as well.
Yes, but also the fact that I really like the point that you said, which is as a data scientist, I do have engineering know-how, but I'm not making the decisions, I'm not leading the decisions,
right?
And vice versa. And kind of to make that transition, I need to be in a position where I'm trained enough to know what's the pros and cons of different options I have, which needs some amount of work to get there.
Yeah,
totally makes sense. Ready for the next question? Okay, what skills do you need to become a data scientist? And the same question for an ML engineer. For
machine learning engineer, I think it's pretty obvious. The name says it all. You need two different skills. One is you need to be good at machine learning. Second is you need to be good at engineering. So when I say you need to be good at machine learning, right, you need to understand the models and not just how to use the models, because a lot of times people tend to use these popular libraries and almost think that they know machine learning. But I really think that to be a good ML engineer, you need to zoom into it and understand what's happening inside the model. Like, what is the maths behind the model? What are the, in what scenarios, what model could be properly used? So you need to have that understanding, and that's a very important skill to build. So yes, understanding the theory, understanding the mathematics is important. Secondly, in terms of engineering, you need to be a phenomenal coder, hands down. Like that's like probably one of the most important skills. But beyond that, you also need to understand the general engineering fundamentals that, so that you can make proper design choices when you are developing a system. And that comes with both reading and actually experience. You read and learn from what other people have done, but you really become an expert at it by designing more and more systems like that. So that's kind of a more acquired kind of a skill.
So I think for data science, it's three-pronged. The first part is, I cannot emphasize this enough, is problem-solving skills. You need to be able to go from really abstract problems into mathematical formulations effectively, and that includes having a good amount of business acumen. So you need to be able to go from, hey, my users are churning, to how can I go from that kind of business problem into a more mathematical problem. So that problem formulation, that communication is really important there. The second phase is the technical part. You need to be good, obviously, at data science. You need to be really good on two aspects in data science. The first being just theoretical data science. I think as someone who's a DS should know what models are relevant at what point, what assumptions are made for these models. Are they valid for the problem that you're looking at? Is the data validating those assumptions for these models? And will this model provide the output of choice, like probability scores versus continuous variables versus classification? So you need to have this good know-how of what model applies where and what the limitations are and assumptions are. And the second part is coding. I think this is very often overlooked for data scientists. Coding is really important. You need to be good at prototyping. Whatever your ideas are, to really be an effective data scientist, you need to go from ideation to execution really iterate really effectively.
Right.
So being good at program skills like working in Python, working in R, super important. And I think the third aspect is, once you have something really fascinating and impactful ready, you need to communicate. Right. You need to work with stakeholders to make sure that it can be productionized. It can be put out there for impact. So you need to work with your engineering managers, with your product managers. You need to communicate with leadership. There's a lot of storytelling for data science. There's why is this problem important? How did I solve it? What is the impact of doing it? So I think it's these three aspects together really form an effective data scientist. last lucky question. Why are you smiling?
Who has a cooler job?
Ah, that's an obvious answer. But I should start. So I think, obviously, in a data-driven manner, I can conclude that a data science job is cooler, a data scientist job is cooler because, you know, at the end of the day, no matter what happens, the data scientist has to sign off on the project. The data scientist has to say, this is making sense, it's a go, this is not making sense, it's a no-go. So whatever happens within, you know, kind of data science wins.
Well, I disagree. And I disagree with all my heart, because a machine learning engineer not only gets to solve the real cool problems and build awesomest models and everything, the most important part being they actually get to build code that is shipped to users. How cool is that? Like, you actually make an impact to users, like a direct coding impact, and that part is super cool to me. Like, I make changes and that's affecting users' life right away.
I guess we can agree to disagree on this and move on and have peaceful lives as husband and wife.
Oh yeah.
But
I don't want to say too much.
Yeah.
I wanted to just tell one general thing that I have noticed quite a bit as part of being in the industry, that machine learning engineers often make this mistake that or not necessarily mistake, but they go into the loop of building the awesomest model ever. And increasing that accuracy metric or that precision or recall from that 95 to 95.2 to 95.5 and 96%, and without often realizing that the product impact of that is not as much. But that takes a lot of time, because we know that taking a model's accuracy from 20 to 80% is a lot easier than taking it from, say, 95 to 96%.
Yeah, that's true.
The last bit keeps on becoming exponentially harder. And what's really important is you build something that works, something basic, deliver a system end to end, and then keep on iterating from there. Because you never know. By the time you have increased the model's accuracy from 95 to 96%, your product requirements might have changed. You actually want to launch things fast to the user and then go ahead and iterate things. So just a little tip that I've noticed.
If you're listening to us, then I'm sure you're interested in data science. This, I think, now is a great time and a great place to be in if you are interested in data science. So, it can be hard in the beginning if you're just figuring out how to get into this area, but you're not limited by not having a certain degree, not having computer science background or something. You can always pick it up with sufficient help online. So definitely keep going at it, and good luck.
Yep. Good luck, everyone.
Yeah.
Hey, I'm Eliza from Springboard. We're an online school that gets you hired. All of our courses come with a job guarantee, one-on-one mentorship, and real-world projects. We teach UX design, data science, and machine learning engineering. To learn more, check out the links below. Happy learning!